Hey there, CS210 students. So let's talk about some of the content in Chapter 2. And again, this will be the first of 2 recordings for this. So in Chapter 2, we are learning how to declare and use variables in our programs. So keep in mind that a variable, all it does is keeps track of a value for something that you want to reuse. Under the covers, you are assigning a memory location with a variable, and then it contains a value. So 2 parts go into declaring a variable. The first thing is that you declare the variable, and then you assign a value to it. So we might declare a variable as x or num people, and then eventually we have to assign something to it. Keep in mind that the equal sign is what we're going to be using to assign a value to a variable. Don't think that you're saying that the two things are being equal. When we say something like x equals 5, what we are actually doing is saying the value of x is getting 5. Okay, so keep that in mind. And then also keep in mind that assignment always happens on the left. So whatever is on the left side of the equal sign is what's going to be getting assigned. So for instance, here we have x equals and then x plus 1. So what this is doing is it's taking the value of what x was, adding 1 to it, and then saving it back to the variable. So keep in mind the left side is what gets changed. The side on the right isn't being changed. Okay, let's go to section 2 and let's talk about integer types of variables. So an integer type variable is going to hold a whole number, could be positive, could be negative, but it's only going to save a whole number type. So declare an int variable, you're going to use the int keyword, and then you're going to give it its name, and then terminating this with a semicolon means we have a storage space in memory called user age that we can assign an integer value to. So scrolling down, so the assignment statement, so we talked about the declaration, the assignment statement is when we actually assign a value to it, and that's when we use the equals sign. So we might have a variable num apples, we're assigning it the value 8, so that's what this variable is going to contain. Take a note here. So one thing that I want you to follow as you declare variables is that each variable should be declared on their own separate line. So if you declare all 3 in one line, you can do that, but it is highly frowned upon in industry because it makes the code harder to read. So if you do that, I will be docking you on the industry standard portions of your grading requirements. So make sure you declare the variables on their own separate line, and then you can see here we're assigning the value litter size, it's getting 3, and then yearly litters, that's 5, and then annual mice, that's a calculated value, so that's why it didn't get assigned anything up here. And so later on when we actually calculate it, then we assign to the variable. By the way, you could have just done this all in one line. You could have said int litter size, and you could have made it equal 3 right here. You could have said yearly litters equals 5. That would be just perfectly fine. So we just talked again. So you can initialize the variables all in one line. In fact, this would be the preferred thing that I would use. If I know what the value is going to be, then you should probably go ahead and assign it. In fact, if the variable is never going to change, then you could declare it as a constant, and we'll talk about that in a little bit later section. Okay, so let's talk about identifiers. So the naming conventions that you should follow. So an identifier is used for variables, functions, class names, and so forth. So basically, an identifier is going to be something that you create yourself. So anything that you're going to create, be it a method, function, name, whatever, here are the rules that you have to follow. So they have to start with a sequence of letters or the underscore. Okay, so you can start with a sequence of letters or an underscore, and then they can also contain digits. They just cannot start with a digit. Now, identifiers in C++ are case sensitive, so if you declare something like numcats and then a capital N numcats. These are two different variables. Fortunately, Visual Studio would catch that this is not the same thing, and it's going to yell at you with some red squigglies. Now, there are reserved words in every programming language, things like int, short, double, for, um, while. So whatever the keywords are, you cannot declare variables that are a reserved word. And so we should have a list of them. It's probably going to be a little bit later. Um, Here it is. So here's the list of C++ reserved keywords. So you cannot declare a variable called operator because it is already a reserved word. Now let's back up here and style guidelines. So we will follow using camel casing for anything that is not a class. So all variable names, all method names are going to be lower camel cased. So they're going to start with a lowercase letter. So lowercase num, and then each new word in the variable is going to get a capital name. So num apples or people on bus, these are perfectly acceptable. Now, you can use the underscore, but I'm going to suggest that you only use that when you're declaring constants. So this is not traditionally done in C++ in production code. Now, in Python, I think kind of the convention is to declare things with underscores. So if you're writing Python code, I think that's okay. But for our C++, I want you declaring them with the camel casing like this. Okay, so let's talk about some arithmetic that you can do. So just like every other programming language I'm familiar with, C++ has addition, subtraction, multiplication, and division. And you work the arithmetic just like you would in mathematics. So it follows order of operations. You do parentheses first. If you had like a negative symbol, so then those are going to be taken care of. And then you do left to right, multiplication and division. There's also the modulus. We'll talk about that in a different section. And then next would be addition and subtraction. And again, it follows the left to right mathematical principle. So keep in mind that you're using parentheses, brackets to kind of combine things. Make sure that you are following the right arithmetic that needs to be calculated. So as we were to be looking at this example right here, if I see the formula with brackets and parentheses, I'm going to mimic that in my code. But keep in mind, you can't use a bracket in your programming statement. You're going to have to write that as a parenthesis. So some more details about arithmetic expressions. So these are all related to using an integer variable. So we might have a down payment that we've entered in, a payment per month, and a number of months that's going to occur. And so to calculate the total cost of what this is going to be, we would take our down payment, plus we're going to take the payments per month times the number of months. Now, they did wrap this portion in parentheses, and that wasn't required here. So again, you've all had some math classes. We know that this would have done this multiplication before performing this addition. But it is kind of a nice little wrapper to say, hey, this is what's actually getting multiplied here, so that visually you can see that. C++ does have what we call a compound operator. So earlier we saw something where it was x equals and then x plus 1. So really all you're doing is you're incrementing that variable by 1. Or what we can do if we want to increment by something other than 1, if we want to go by 5 or 6 or whatever we want, we can use these compound operators where not only do they do the arithmetic, but then they also save back to the variable. So for instance, this right here, user age plus equals 1, that's the shorthand notation for writing it out, where we would say, grab the value of the user age, add 1 to it, and save it back to the variable. Unfortunately, in C++, if you have big numbers, you cannot write them with commas, so that makes it a little bit hard to read. So maybe a good thing to put out if this was like a constant is maybe what it is in, like 1 million and typed out in words. again, as a comment. Okay, next section we're going to look at here. So instead of talking about integer types, now we'll talk about a float or a double data type. So anything that's a non-integer, so any kind of real number, we can treat as a float or as a double. So the idea of a float and double is that they hold decimal type numbers. Now you can save integers to them, and we'll talk about that in another section here. But the idea with these is they're usually going to hold a decimal type number. Now, the difference between these two is the precision that they hold. So a double is always going to be able to hold more precision than a floating type number. So if you need a very precise calculation, you're going to use a double. A less precise, you could use a float. We'll also see in a different section where the memory size of these is a little bit different. So when do you choose the variable types? So integers are typically used when it's going to be something that's counted. You got 42 cars or 10 pizzas or, you know, anything that's going to be an integer type value. As they say here, floating point types typically used for measurements, so degrees, meters, and so forth. Floating points are really good for things like average number of cars, money, and so forth. Oh, well, they actually point out that money should be represented using the actual dollars and cents separately, but we're not going to worry about that for our class. So in C++, we can declare constants. A constant is a variable whose value will not change. So if we have something, for instance, the speed of sound or seconds per hour, things that we know are not changing, then we can declare them as a constant using the const keyword, its data type, and then the naming convention is to use all capital letters separated by the underscore. So this is typically done in almost every programming language. So later on, if you try to assign speed of sound a value, it's going to give you a compiler error because it knows that this is a constant. Once it's declared, you can't change it. Next up is the math library. So C++ has a math library just like every other programming language. So these are things that are outside of addition, subtraction, multiplication, and division. So for instance, like you want to calculate the square root. So to include the math library, you have to have an include statement with C math. So just like this is going to include the math library. Now, once that's included, you can then reference all the methods and functions that are in it. So the square root, we type out sqrt, and then you give it the value that you want to square root. One thing that you need to keep in mind is what kind of inputs do the values take, and then what kind of output do they provide. So a square root, you're going to be able to give it a double type number. You could give it a float, you could give it an int, so a double covers them all. And then what is this going to return? So when you take the square root of something, here they're showing you that it's 7.0, so it's going to return a double value back. So we're going to declare our variable to hold a double since that's what's going to be returned here. And again, there's many different functions available in the math libraries. You got square root, the power function, so where x is the base and y is the exponent, absolute value. So all sorts of math functions available to you. You can scroll through and read more about those on your own. Last thing we'll talk about for this recording is integer division. So just like in Java, if you attempt to perform division using integer values, doesn't matter if they are literal values like we see here, they're the hard-coded numbers, or if I have variables that are assigned with an int data type. So in C++, just like in Java, when you perform division using integers, you get an integer value back. And what it's going to do is it's going to truncate off any potential decimal value that it would have had. So 10 divided by 4 we know is 2.5, but you're going to get 2 back. It's the integer portion that it can save. 3 divided by 4, in fact, any fraction that's going to be less than 1, when you perform integer division on it, you're always going to get 0 because, again, the decimal portion gets chopped off. So we will see in the next section how we can alleviate that issue. In fact, they kind of show right here where if I've got variables, one's an integer and one's a double, then this will perform the arithmetic properly. 10 divided by 4.0, it's going to yield 2.5 as long as you save this back to a double. And oh, by the way, another kind of shortcut that you could do to make this division work is instead of dividing by 4, you could make it 4.0. So this would understand that it's a double and then perform the division properly. And again, you'd have to assign the result to a double. Okay, that's it for this recording. Look for the next section to be handled in a different recording.